Hi everyone, I hope you're doing great. Today I'm going to show you how to create a script that generates a parametric tower for you. The way I'm going to create that tower is by creating a central axis first and then creating two profiles, one at the bottom of the curve and one at the top side of the curve, and later dividing that based on the placement of the floor plates and then move forward. So what I'm going to do is to first, let me put this side by side so you can see it. So I'm going to construct a point in my Grasshopper. You can also pick something. I want to create from scratch, and I will leave this point to be at x, y, z coordinate of 0. Then I'm going to copy and paste it. The other point, I just want to move it in the z direction, and let's say that my tower is like having a height of 30 meters. So I can enter a slider and set that number to be 30. So this is, and the units are relative, so it depends on how you have set up your units. I can check my units to see what they are. Let's see. I can set them to meters. Okay, and go back to my Grasshopper. Next, I'm going to create a line that generates that axis for me. And this line should be, when I open line, there are different types of line. I want the second line that creates a line between 2 points. So I select my 2 points and I have my line. Next, I'm going to put a profile at the bottom and then a profile at the top. So for that, I'm going to bring in polygons, and when I bring this component to the canvas, you see that it automatically generates this polygon for me at the bottom. You need to set a radius for it. So for example, 3 meters is probably very small. Let's say we can set it to something around 22. Oh, and I need to make this 300 because I changed my units to meters. Okay, this sounds about right. So it's a very slim tower. So you can set the radius to a number, and then the center or the point around it, it's by default your coordinate. You can also connect to it so that it gets rid of that plane that was automatically generated for you. The same way for the bottom one. So this time this top profile is generated here, and you can rotate the top profile so that we aim to loft these two profiles. So I'm going to bring the loft first so that you see how this will look like. So this is a straight extruded tower. What I want to do is rotate the top profile so that it creates a different surface geometry. So I'm going to rotate this geometry, and I'm just gonna replace it. Let me first disconnect this from the loft and then add the rotated version. So we don't know exactly how much this is rotated. I'm going to hide my old profile so that we only see the rotated one. So for the angle, by default, the angle of rotation is not in radius. We need to put a component that transfer whatever degrees into radius. So we bring that, and let's say we want to rotate it 45 degrees. I type in 45 degree, I connect it to here, and then I connect it to the angle. If you hover your mouse over angle, it is now showing the angle of rotation. I can reduce it. See, we start from 0. And let's say 30 degrees is what we want. Okay, so if I want to organize my script, I can group this and bring in scribble. I say this is my tower axis, and you can add it to the group. Then these are my, and it depends how much you want to break it down. You can either group these as base profiles and then lofted or rotated tower, or I can group them as one piece and then bring scribble again. This time I say this is my lofted tower, and I add this to the group. So next, what I want to do is I want to divide my axis to whatever number of floors that I'm imagining exists in this tower, and then put floor plates in it. Okay, now I want to divide my axis to get central points of my floor plates. The curve that I want to divide is my axis that I created here. So this line is going to be placed here, and by default there is a default number of divisions. It's probably 10. You can imagine that the height of the tower is constant, so instead of a slider I can bring in a panel that indicates that the height of my tower is not going to change. And if this is a constant, then I can say, okay, if every floor to floor height is 3 meters, for example, then probably you can either calculate it, say I'll get 100 floors, do an equation that divides that, or do it in your head. So I'm going to right now divide this by 100. Let's see, 300 divided by 3 meters, that is 100 floors. I can make this parametrically as well, so I can say whatever this number is, division divided by my floor height, which is also a constant number, 3 meters. And then let's bring a panel to see what that number is. It's the same number, it's 100, so I'm gonna put that in. When I'm looking at this tower, I feel that it's a lot of floors right now, and the radius is a little bit big for that many of floors. So I'd really want to change the height to 150 so that I'll have fewer floor plans. So now that I have these floors, I have these division points across this axis, I want to cut my tower and get the floor plate at each intersection, because remember, this is a rotating tower, so the floor plate is not repeating across different heights. So for that, I need to put an XY plane on XY plane around each point. And when I bring that XY plane and connect my point to it, you see these planes that are placed here. So you might say, what's the use of it? So a plane has unlimited extension in X and Y direction, and that is going to be used to intersect that plane with the outer boundary of the loft tower. So for that, I go to intersect menu, and this first one is intersecting a B-rep with a plane. Plane is that XY plane that I just brought to the canvas, and then B-rep is the lofted tower. So I bring that to here, and I connect P to P, that's plane to plane, and then I have my lofted tower. I connect it to B-rep. It takes a while to calculate, and now you can see these lines being projected on my lofted tower. So these are lines. I need them to be, let's say I want to calculate the area, the total area of floor plates in this tower. So I can make a planar surface. Let's see where that I need to go to surface, boundary surfaces, so that's the name of it. So I can bring a boundary surface, and it needs a list of edges to create surfaces for me. I can connect this, and now I have all of these floor plates generated for me. Let's take a panel and look at what I have. So each one of them are created in its own layer or in its own list. And if I right click on it and flatten the list, then they are in big one list. The reason I'm doing it is that I want to add the area of them, and they need to be in the same list. So then I bring the component area, and the area I need to put the geometry in. The output is area as well as the centroid. All I need is the area, so I'm going to connect it to the panel. I see the list of areas of all of my floor plates. They are 51 floors, and I need to add them together to know the total footprint of this tower. So let's see if addition is what I want to do. So addition, I need to have, if I want to use this, I need to extract each one of them and put them one by one. There's another component named mass addition, and I can bring that in and connect these areas to the mass addition. And now if I bring another panel and connect it to results, this is the subtotal of all of these floor plates that you're going to get. So yeah, this is a simple tutorial on how to create a lofted tower. I'm going to organize this furthermore, and I'm going to name this as building floor plates. Add this to the group, and then this is a calculation. So for example, if you want to think about this parametrically, one might say that my maybe the rotation angle, this is let me remove this from group and bring it out. I like to maybe change the color of my variables so that I know what is them changing. So one might say that the height of the tower is constant, maybe the shape of the floor plates is constant, and my variable is the angle of rotation. One might create multiple like cross sections for the base or for the top or for both of them, and those are the variables. One might play around with the radius of the floor plates. So this tower, let's say that there's a certain target of floor plate surface area that you need to meet, and then you have freedom over the geometry, etc. So creating a parametric definition like this will allow you to explore the forms of those variations. Yeah, that was today's tutorial. I hope you enjoyed it. Have a very good day, and bye.